Hey friends, welcome to Friday. Today is Focus on Astrophotography Friday. I'm going to have the broadcast today, and Tyler is not going to have his 4 o'clock show because he's traveling on business and he'll be on his way to an airport to fly back here. He's been over on the East Coast taking care of some Explore Scientific business. So anyway, today we're going to talk about business. Today we're going to talk about astrophotography and getting started. It's a show we do on a regular basis because of light pollution. The future of astronomy in many ways is in astrophotography. So we're going to go down that road and teach y'all how to do some of this stuff. If you're out there watching, we'd love to hear a howdy or a shout out from you. Any comments and questions as well. Today, during the show, warming up for Amazon Live, we're going to be talking about the EXOS 100, the O2 version that will be Bluetooth capable when we finish up the Explore Stars 2 app, new app that'll run on a smartphone. As it stands right now, the app which is Explore Stars, download from your apps or Google Play Store, whatever, will run on a iPad with a screen of at least 7 inches and a Android tablet, again, with a screen of at least 7 inches, and a Windows tablet, a Windows desktop, or a Windows laptop. People can get them to run on the Android device, on a smaller device, but the buttons get so small that you can't touch the buttons, which makes it not really usable. The EXOS 100 is a go-to tracker. So what it does is it mimics a tracker, mimics the rotation of the Earth to negate it. So wherever you point your telescope or point your camera, your telescope, whatever, with a tracker, it's just running in the right ascension, just negating the rotation of the Earth. You have to point it where it's going to go. This mount allows you to control it in the declination axis as well, and it has a go-to capability. You can tell it to go to anywhere in the sky you want it to. Now, one of the important aspects of that is you have to get this axis pointed north. And the way you do it is, here's how I do it. Unlock the clutch, turn the deck housing so it opens a little port, remove the polar tunnel plug, and you can look through here. What I do is I have a green laser, and I literally just shine that green laser up through the polar tunnel, and after dark I can see the green laser and it points where we are looking at in the sky. If you're off of Polaris, you simply move the mount left, right, up, and down using the altitude connection control right here, and you can loosen this a little bit and move it a wee bit and get it pointed and then tighten it back down, and you're going to get a really close, if you do it well, a really close rough polar alignment. Now, the beauty of this mount is the motors are micro stepper motors. They're digital. They have a circuit board in there that we can program the torque limits. So as it's counting the micro step, if it gets way out of balance or runs into something, those micro digital motors break the torque limit and they just turn off, turn back on. Makes a chattering noise as they turn off, turn on, turn off, turn on, turn off, turn on. Sounds bad, doesn't do anything other than lose the micro step counts, so it doesn't know where it's pointed anymore. You have to manually, electrically run it back to the home position, turn everything off, start over. But that's great protection for your mount. The direct drive or the DC stepper motors or servo motors on previous mounts, going back into the original really good go-to mounts up in the early 90s, those are servo motors. You apply electricity and they run full bore. And if the telescope runs into something or gets way out of balance and can't overcome the weight, those motors just start chewing up the gears. And that's not going to happen here because those digital stepper motors are going to let go, and it's going to keep the system from tearing itself up. Right now you're looking at the original version. That's the EXOS 2 GT with PMC8. It is a mount that obviously holds a big telescope. It's rated up to 28 pounds of telescope and astrophotography gear for astrophotography, or up to 40 pounds for visual amateur astronomy. So you can put a pretty heavy kit on there and go. This is the newer version, built smaller. It's rated for 9 pounds of telescope, lens, and camera gear, or I think it's 16 pounds for visual. I will say we have a customer out there, JR, who shows up on our broadcast from time to time. He's running a Maxitov Cassegrain 180 millimeter diameter telescope. It weighs, with his cameras and stuff, 24 pounds. He operates at a really long focal length. He has a lot of counterweights on it, and he makes it work. Managing the balance is the key. He's exceeding our parameters, but you can do that and do it successfully. It may shorten the life of some bearings and some other surfaces, but you can do it and do it successfully. It's a very powerful little mount. It was designed actually with cameras in mind, and comes with a light tripod that when you put it all the way down on the ground, works really well for astrophotography. So how we hook up a camera to it is like this. If you already have a DSLR, and this is a older Canon D5, or 5D, I'm sorry, it's real straightforward to hook up to your telescope. You simply get our DSLR camera adapter right here, which you can get off the website, and you simply attach the camera to it just like you would any tripod. Slide it into position, and then you're going to need to balance the camera or telescope. But we advocate, if you already have a DSLR, you're ready to go to start astrophotography with this mount. All you're going to need is the mount and the camera adapter. You'll also, we advise you to buy the power bank flashlight, which will power you for a couple of nights easily. So I'm going to check the balance to make sure it's in good balance, and look at that. It's in good balance. It's not going anywhere. So back to the home position. Now I'm going to check the right ascension and see how well balanced it is. As we can see, I am counterweight heavy. So I'm going to move this one counterweight all the way up, because I sort of know where the balance point is. Loosen the clutch, and there we go. It's a little bit, let's see. It's a little bit counterweight heavy, which is what I want. Why do I want it a little bit counterweight heavy? Move it up just a little bit. Why do I want it counterweight heavy? Because if you have it perfectly balanced, it can flop back and forth between gear mesh. If you have a tight gear mesh, you're going to tear your gears up. If you have a loose gear mesh where they turn, they move freely. You can get them real loose where they'll wobble back and forth. But even with a standard gear mesh, the gear teeth can move. And if it's perfectly balanced, it can be driving, but it can flip back to the other side and not be in contact with the teeth. And so for a period of time, it, like wind, for instance, can cause it to blow and disengage the teeth. Therefore, the mount, the motors are turning, but the mount doesn't move until it re-engages the tooth. So by managing your weight distribution, a little bit camera or eyepiece heavy, and a little bit counterweight heavy, yeah, hey, we're going to get there. I'm explaining why. And a little bit counterweight heavy, that keeps it, the gears engaged, and it's always in contact with the gear teeth. Paul says he's heard debate about that. There's debate on everything. So, what have you heard, Paul?
I don't know. Annie was talking about the other day.
You know, everything I've ever seen, and mechanically, that makes perfect sense to me. Perfect balance is going to give you problems, because if the wind blows or the weight, moves a little bit, the camera turns, and when the camera lens turns, it's going to change it a little bit, and it can change with the tooth engagement on the gears. That's a problem. That's going to cause things to stop moving. So you can have it front heavy and telescope heavy. That's fine. Or you could have it front heavy and counterweight heavy. Or you could have it back heavy and counterweight light. You can, there's what, 4 variables in there? You can change it how you want to. The whole method, the whole thought is to keep the gears engaged, right? And if you keep them engaged by managing your weight, you're not going to have a problem, right? That's the theory of it.
Eat more salad. Right?
Eat more salad would also help keep you very regular.
You manage your weight.
if you eat enough salad and not enough of everything else. Or, yeah, you know what I mean. So anyway, so how do you run this mount? So I've got it hooked up with the power bank flashlight, and it's real simple. We simply turn it on, and I've already loaded the appropriate app, Explore Stars, on my iPad. I'm going to fire it up. I'm going to very first make sure by double clicking to make sure that the app is not running in the background, and it's not, because if it was, I'll show you what it would look like. It'll look like that if the app's running in the background. Well, if it's already running in the background, you want to close it simply by flicking it off. On the Android button, I think you press the square button, and then it comes up with a very similar window. So I am going to now go to the Wi-Fi, and it should see a PMC8 pop-up. Yes, here's PMC8 6358. It is 6358 is the name of this mount. It's a unique name. And I'm going to tap on it, and I've already been hooked up to this one before. Otherwise, I'd put in the very secret password, PMC-8 EIGHT. It's uppercase, lowercase, just like on the name you see of the mount right there. So obviously, it's not that super secret of a mount. Now I'm going to launch the app, and I'm going to check it real quick by, see if I can do this, by just getting a virtual joystick. And there it goes. It moves. So let's just hit menu, catalog, solar, sun, slew to object, and I have auto slewing off. So I am going to click the go to button. And there we go. We're going to go off to the sun just like that. Now, if you start with the camera pointed due north and the counterweight bar straight down, you're going to have a really good go to, assuming you have a decent polar alignment. The key to it is understanding that it starts the motor count, assuming the counterweight rod is straight down and the camera is pointed directly at the north celestial pole. If it does, then it's going to go exactly where it is. A few weeks ago at Fort Worth, I've talked about this before, a few weeks at Fort Worth Camera, one of our new dealers, we went down to do some stuff with them when they had a show. And Tyler and I used a compass to do a polar alignment. We lined it up. I was just standing back 15 feet with one eyeball closed, looking down the compass, and had him rotate the mount left and right until I thought it was lined up with the magnetic north. Excuse me, not magnetic north, but with true north. We set the latitude to 32 and didn't execute a go-to. We went straight to the sun. We were on the sun. We didn't have to move it left, right, up, or down for over 5 hours with an ED-80 on the telescope doing astrophotography. A number of people put their cameras on and took pictures of the sun. We had a sun catcher, solar safe, sun safe sun catcher on the ED-80, and it was fantastic. So that's what we're going to be talking about. We're going to do this a little bit more on Amazon Live. We're also going to talk about how you hook up an ED-80 with the camera you have as well. Other telescopes, the same process. We're going to show you how you can hook up an ED-80 and take pictures with a telescope. Now, if you're using a zoom lens and an autofocus lens, you're going to want to turn the autofocus off, and you're going to want to focus with the manual focus ring. And if it's zoom, you want to get the zoom level where you want, and then you need to tape it down with gaffer's tape or painter's tape or something like that. Something that doesn't leave a sticky residue. So it's called lens creep, Paul says, and he's exactly right. Like this camera lens, I can do it right now. I can zoom in, right, from where it is, and watch what happens. As soon as I let go, it's going to start, it may not, but it will sooner or later.
Yeah, if you just move it back and forth a little bit, it'll sink.
Yeah, so it starts sinking, right?
Move this
There it goes. There it goes. So as a little wind, a little bump, it moves, and your shot is going to be all goofed up, and that's not what you want to do. So we're going to go ahead and shut down here real quick. We'll be back up on Amazon Live at exactly 2 o'clock. We look forward to talking to you all over there, and appreciate you giving us a little bit of your time this afternoon. It's Friday. I am Kent Marts, and we will see you in a few minutes. Bye-bye.